Hey everyone! This tutorial is an update to our previous video, updated satellite images every 2 to 3 days, which we posted on the GeoRGB community YouTube channel back in May of 2021. The reason for this update is that Sentinel Hub's EO browser is no longer available. As you can see, if we try to access EO browser through the link we shared on giscourse.online, under the Resources tab, we'll find a message stating that EO browser will no longer be operational. It suggests that moving forward, we can use a platform called Planet Insights. However, if we try to click Login to EO browser, enter our credentials, and hit Continue, we quickly realize there's no access anymore. Instead, it suggests we check out the Planet Insights platform, which is a paid service, or the Copernicus Browser, which offers free access. For this tutorial, we'll be using the Copernicus Browser. Let's dive in. Just a quick heads up, folks. The giscourse.online website has now been updated. You can actually access the Copernicus Browser directly through a new link in the Resources tab. I'll make sure to leave the giscourse.online link in the video description for your convenience, So you just click that link to head straight to the browser. Once you're there, you'll want to hit Login to get signed up. Accessing it as an anonymous user has quite a few restrictions, so it's best to register. Go ahead and fill out the form that pops up, then just click the Register button. Easy peasy. Okay, so once you're registered, you just need to pop over to your email to verify everything. Pretty standard stuff, After that's done, you're all set to dive into the platform. Now, when you hit the dashboard, you'll see your available credits. Don't sweat this part at all. It's really just a way to make sure nobody's hogging all the resources. You're not getting charged for anything, and those credits actually top themselves up every month, completely free. Honestly, 30,000 credits is way more than enough for pretty much anything you'd regularly do with satellite imagery. So, to actually get to those satellite images, we just click right here on Copernicus Browser. Let's go. All right, so because I don't want this tutorial to go on forever, we're just going to do a super basic run-through of what you can actually do here. Starting off with the main panel, you'll see the Visualization tab. This is where you can manually search and pick out specific areas, whether you're looking for just one image, a whole mosaic, or even a particular range of days. Right below that, we've got a calendar. This is where you can punch in specific dates. And here's a neat trick. If you zoom in to about a 50-kilometer scale, you'll unlock the cloud coverage percentage option. You can totally adjust this to suit your needs, but just a little word of caution. Sometimes your area of interest might be perfectly clear even if the overall cloud coverage is, say, 95%. So, keep an eye on that. Depending on how restrictive you are with that percentage, you'll either see more or fewer available images for your zone. The days with images that meet your cloud coverage criteria will be highlighted a bit darker on the calendar, so they're easy to spot. You can also check out current events that are flagged as highlights. There are all sorts of topics. Just pick what you want to see: agriculture, geology, you name it. Next up, we can select our data source. There's a huge variety here, but for this tutorial, we're going to stick with Sentinel 2. It offers a pixel resolution ranging from 10 to 60 meters, depending on the band you're using. And speaking of bands, here's a little visual with the different resolutions for various band combinations. After that, you can pick your default band composition, like true color, false color, NDVI, and so on. Or hey, you can even create your own custom composition, maybe something like 736, Now, the Search tab is where you can do a more advanced search using filters. This is super handy for downloading full tiles of the area currently displayed on your map. For instance, if you select Sentinel 2, mark your cloud coverage, pick the satellite you want, set a date range, and then hit Search. It'll pull up all the available tiles that match your criteria. Pretty slick. All right, so over on the right-hand side panel, we've got a bunch of different functions. You'll see the loaded layers, which by default is a true color mosaic from the Sentinel 2 satellite, using images taken between April and June of 2025. But hey, you can also switch that up to an OSM background, and even add country borders and name labels, Then there's a whole suite of other options. You can get more information, create a specific area of interest, draw lines, drop a point of interest, measure distances right on the map, download images, and a whole lot more. Now let's actually try downloading a true color image of a specific area, just as a practical exercise. This'll be fun. Okay, let's start fresh, eh? This way I can pick out an interesting area, like maybe the Barcelona airport in Spain. For this example, we're going to create an image based on the true color composition, which is one of the default options here. That's using the B4, B3, and B2 bands. Okay, so to download your area of interest, you'll want to click on the Download Image option. Now, to get that image geo-referenced, meaning it has those coordinates baked right into it, you need to select the Analytical tab. You can toggle the logo option on if you want it in your picture. I'm going to leave mine off for now. Next, pick your image format. Since we're going for a high-resolution image here, I'm choosing the TIFF 32-bit float format. Before we set the image resolution, we need to pick our coordinate system. I'm going with UTM because I really want a system where I can measure in meters, so I'll select Mercator, which is a projected system, as opposed to a geographic one. As you can see, the indicated image resolution is pretty low right now, 19 meters per pixel, but we can actually pull a better resolution thanks to the bands we're using. That's why we need to change the image resolution from medium to high, and boom! Now we've got a pixel resolution of 9 meters. That's even better than the sensor's native 10-meter resolution. I guess that's a recent improvement because it used to be capped at 10 meters per pixel. Next, we'll select the type of image we want to download. I'll pick True Color, but there are different default options, and you can even download the individual bands if you want to create your own compositions later in software that allows you to combine satellite bands. Now we just hit Download to grab that image. We choose a destination folder, and just like that, you've got your satellite image ready to go. And the best part? It's already geo-referenced. Let's quickly open this up in QGIS to see how it looks. We'll load it as a raster image. I'll also bring in a Google Earth satellite image to cross-reference and see if the overlap between the two images is correct, which will confirm our image is properly geo-referenced. And that's everything for today. I really hope you found the content of this video useful, eh? Don't forget to hit that like button and leave a comment if it helped you out. Thanks for watching.